Okay, we're going to talk about area and perimeter of regular polygons. So remember, if it's regular, we have congruent sides, and congruent means equal, and congruent angles, which means the angles are equal to each other. So the formula for the area is going to be 1/2 small a, big P. And we're going to talk about what those are. So big A is the area. Little a is the word apothem. And I'm going to show you what that is on the pentagon over there. And then P is for perimeter. So you have to know the perimeter before you can find the area. All right, so the center of the circle, of the polygon, is the same as the center of the circle. So you could think of the radius as from the center of the polygon out to any of the corners. The apothem is perpendicular with the sides, shorter than the radius, bisects the side. So this is our little a right here. These two sides are going to be equal to each other, and it's going to form a right angle. And of course, when we have a right angle, we're going to use some kind of triangle in there. Okay, so we did the center, the apothem, the radius, and we did central angles before. So the central angle is the angle between basically the radius, two corners that go from the middle right here. So this is our central angle. So our central angle is in red. Right there. There we go. Okay. So you have to, for the central angle of the polygon, you have to connect two radius to two corners, and the angle that it makes from the middle is going to be your central angle. So if we want to find the central angle for a pentagon, we're going to take 360 and we're going to divide it by the number of sides. So we used this last time and we called those the exterior angles. But since now, and we were talking about the angles outside, and we were talking about the angles for the corners of the pentagon. Now we're talking about the angle from the center of the pentagon to two vertices. So for a pentagon, we're going to have 360 divided by 5. And that's equal to 72 degrees. So actually, this is how much it is in the picture up here that was a pentagon. The central angle that I did in red is 72 degrees. All right, so a regular triangle has 3 sides. So we're going to have 360 divided by 3, which is 120. And a regular nonagon has 9 sides. So we have 360 divided by 9, which is 40 degrees. So it's relatively easy to find the central angle. And then we're going to show all the different ways we can find the other things that we need. Okay, so here's my hexagon. So I'm just going to draw the center right here. I'm not going to try and draw a circle around my hexagon because that would be pitiful for me to try and draw. Yeah, not going to happen. Okay, so never mind that. So the center is right there. The radius is going to be right here. The apothem, remember, goes down to the middle of the side. These two are equal. This is my apothem. And my central angle is going to go from here to here. This is my central angle. Let's see if I can make it really small. Central angle. There we go. Okay. So now you should be able to see where all the different parts are going to come from when we're finding our area. So the first thing we're going to need to remember that we need the perimeter. The perimeter is add all the sides. Luckily, we're always talking about regular polygons. So I have, my side is 14 and I have 1, 2, 3, 4, 5 sides. So my perimeter is going to be 5 times 14. And that is going to be 70 centimeters. If you noticed on your last, well, maybe not. I'm not going to talk to y'all about putting the units on there and taking points off if you don't do the units, which could happen. All right, so now we have to find the apothem. So think about, well, we know the apothem. So think about what else we need. I'm looking at those notes and I'm like, I don't know what happened. Okay, so we have the apothem. So here's my big P. My little a is 9.63. My area is 1/2 AP, so that's going to be 1/2 70 times 9.63. And, you know, remember when you're doing this that if you'd rather put it in your calculator as 0.5 times 70 times 9.63, you can do that. And that ends up being 337.21 centimeters square centimeters. Okay. So if you're given the apothem and a side, then it's easy to find the perimeter and find the area. But of course, we're not always going to make it that easy because what's the fun in that? All right, so for the next one, we have the apothem is a little a, that's 12. The radius is 13. And of course, you see our little triangle we have here. So we're going to take this triangle out. So here's our 12, 12, 13, and x. We're going to call this side x. Now remember, there's 2 x's on the bottom, and that's going to make one of the sides. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have an octagon. So it's got 8 sides. All right, so we're going to use Pythagorean theorem. We're going to do a squared plus b squared equals c squared. So we have 12 squared plus x squared equals 13 squared. So that's going to be 144 plus x squared equals 169. We're going to subtract 144 from both sides. Hopefully, it's going to come out to be something like 25, so that when we take the square root, it's going to be 5. So what we know is this is my x. And my x is half of the side of the octagon. So if I have 2 5s, that means that the side is 10. And I have 10 sides. So my perimeter is going to be 10 times 8 sides, is 80. My apothem is 12. So my area is going to be 1/2 12 times 80. So that's going to end up being, since I'm doing this in my head, 6 times 80. And I know 6 times 8 is 48 with a 0 on the end. And we don't have any units for this one, so we're just going to call it 480 for the area. Okay, so yes, you're going to have to do multiple steps for most of these problems because they're going to give you part of the information, but not all of the information, which is how we roll in math class. All right, now we have a triangle. So it's equilateral, means it's regular. That means all the sides are 4. And we could, instead of doing the apothem, we could just draw a line down here, right? So that means this side is 2, this side is 2. If we're looking for the height, we're looking for this. It's almost easier just to think of it not as using base times height. So, Pythagorean theorem, or our special triangle, because remember this is 60 and this is 30. So we could use a 30, 60, 90. Remember, we have x, 2x, and x square root 3. So if our 30-degree angle is across from the 2, that means across from our 90 is 4, which we already knew. And so across from our 60 is going to be 2 times the square root of 3. You could also do a squared plus b squared equals c squared. 2 squared plus b squared equals 4 squared. And it should come out to be the same thing. So we have 16 minus 4, which is 12. So b squared equals 12. And b equals the square root of 12, which happens to be 2 times the square root of 3. All right, so that's our base, our height. So to find the area, we could just do 1/2. 4 is the base. 2 times the square root of 3 is the height. So if I do 1/2, of 4, that's going to end up being 2. So I have 2 times the square root of 3, which is equal to 4 times the square root of 3. And if you wanted to change it to a decimal, you could put 6.92 centimeters square centimeters. Either one of those for the answer, depending on what the question asks you to do, asks you to find, or asks you how to write it. You know what I mean. Okay, square. Square should be relatively easy because the sides are equal and it's a square. But all we know is this weird little side right here, which is 5 times the square root of 2. So, since all the angles are right angles, we know that when we cut it with that's the radius, remember? And this is the apothem. So, we have a 45, 45. So, we're going to write our little 45, 45, 90. This is the easier one because it's x square root 2. And when they're so nice that they give you 5 times the square root of 2 for the 90, then you know that the other two sides are going to be 5. So A equals 5, and half of the bottom equals 5. So we know that the side's 10, because this is going to be 5 also. So the sides are 10, and we could do 10 times 10. So the area equals 10 squared equals 100. If you wanted to use 1/2 the perimeter, let's just see if that works. If we use 1/2 A perimeter, then we have 1/2. We know the apothem is 5, and the perimeter is going to be 4 times 10. So we would have 1/2 times 5 times 40. And because I'm doing this in my head, I'm going to take half of the 40, which gives me 20 times 5, which gives me 100. So both ways work to find the area. But again, you're having to use your right triangles to find whatever sides are missing. All right, so we have a hexagon. Hexagons have 6 sides. We know the radius, and we know this is 60, so that means we have a 30, 60, 90. So let's remember our 30, 60, 90, which we did up there a minute ago. So it's all fresh in your mind, and you're like, oh yeah, I remember that. X square root 3. So which one did they give us? They gave us 6, which is across from the 90, which means across from the 30 is 3. That's going to be right here. And the apothem is going to be, so that's the little a. This is half of our, 3 is half of our side. So it happens that if these two are 3, that the sides of my hexagon are 6. So the radius happens to be the same as my sides. Doesn't always happen that way. So my apothem is 3 times the square root of 3. My perimeter is 6 times 6 because I have 6 sides. So it's 36. And my area is 1/2 times 36 times 3 square root 3. So, as I always do, I'm going to take half of 36, which is 18 times 3 to the times the square root of 3, which is equal to 93. I'm just going to give it to you. 0.53 square meters. Could have done 18 times 3, which would have been 30, 40, 54 square root 3, which is the same. Those things are the same. So those are equal to each other. Okay. The area of a regular pentagon with side lengths of 10. So this time we know the side lengths, which means we know that this is 5. Ooh, and they gave us that ugly angle 36. And of course, this problem's not done on my paper that I'm cheating from. So, oh, that's 16, isn't it? I kind of wrote over it. Okay, let's try that again. Okay, so this is 16 apparently. Okay, which means this is 8 and this is 8. And we have this weird angle. So we're going to not be able to use 30, 60, 90. So we're going to have to go back in time to our sine, cosine, tangent. So let's think about this for a minute. This is the opposite side. This is the hypotenuse. And this is the adjacent side. And we would like to find the adjacent side. So adjacent over, we want this one, and we have this one. So we're using opposite and adjacent, which, if I remember correctly, is tangent TOA equals opposite over adjacent. And I forgot to put my x right there. So tan 36 equals 8 over x, or little a. We'll just put little a right there because that's going to be our apothem. All right, so I'm going to have to get my calculator out here, and you'll have to listen to me try and figure it out on my phone. And I'm going to do tan. So let's solve. If the a is on the bottom, that means we switch our guys around, which means a is equal to 8 over tan 36. So let's just go ahead and work that out that way. So 8 divided by tan 36 equals 11.011. All right, so that's my apothem. My perimeter is 16 times 5, which is 80. So my area is 1/2 80 times 11.011. Half of 80. Hope I drive you all crazy doing this. Maybe I'll do practice your math. So that's going to be area equals 40 times 11.011. And that is equal to 440.44. And that would be square inches because we have inches squared. All right, last one. Okay, so they gave it, oh, it's one of those working backwards one. Here's the area. Here's the apothem. We want to find the perimeter and the side length. So we know we're using the area, well, we're using the formula we learned. There's only one. Okay, so we're going to have 1/2 AP. So we have 144 equals 1/2 4 times the perimeter. So I'm going to go ahead and do 1/2 of 4 because that'll make it easy for me to solve. So I have 144 equals 2 perimeter, which means I just have to divide both sides by 2. My perimeter equals 72. So that's my perimeter, 72 meters. And then since it's a hexagon, there are 6 sides. Did I say that? Okay, and so one side is going to be 72 divided by 6. And 72 divided by 6 is 12 meters. So one side is 12 meters and the perimeter is 72 meters. Okay, so a little trig, a little Pythagorean theorem, a little special right triangles, and a new word apothem that you have to remember